So yesterday we started with the AC circuit analysis and we discussed sinusoids. So an AC voltage or an AC current can be represented as a sine or a cosine waveform, and mathematically it is represented by uh, Vt as a function of time. Vt is equal to Vm sine omega t or cos omega t plus phi. Now today we'll be discussing phasors. A phasor is another representation of AC voltage and AC currents. Uh, आपकी waveform, the waveform will still be sinusoidal in nature only. It's only a mathematical tool that we can use for uh, solving certain at which many instances we'll see that representing voltage or current through phasors is easy to solve mathematically as compared to uh, representing them through a sine or a cosine waveform, right? So this is just a simple mathematical representation of the same sinusoidal waveform. Now, what is a phasor? Phasor is a complex number. It's actually a complex number representation that gives the so we now have this we have the sinusoidal waveform. We have the sinusoid. Now we want to find its we instead of representing it in terms of a trigonometric sine or a cosine function, we represent it in terms of a complex number. So for that we use phasors. Phasors is simply a complex number representation of the sinusoid through its magnitude and angle. Right? We know that complex number z is given by x plus jy. Right? J here is iota under root of -1. Instead of writing I, we use the symbol J here because we do not want to confuse it with the current symbol that is I. So in engineering, you will see that mostly J is used instead of representing iota by I. Fine. So we have a complex number x plus jy. Associated with this complex number is the magnitude and the angle waveform. So on a complex plane, we can represent any number x plus jy where your x-axis represents the real part of z and your y-axis represents the imaginary part of z. Now with this particular complex number will have a magnitude and also it will have an angle or a phase, you can say theta, say for example. Now this magnitude r is given by under root of x square plus y square, and this magnitude angle theta or phase theta is given by tan inverse of y by x. So this you already know for a complex number. Also this complex number, once you have this r and theta, you can also represent the complex number in a polar form by having its magnitude written and then its angle written. Fine. So this z equal to x plus jy is its rectangular form. Z is equal to r angle theta is its polar form. Also, you can write it as r e raised power j theta. This is the exponential form of the complex number. We also know for a complex number that x is simply r cos theta and y is nothing but r sine theta. Therefore, you can also write z equal to r cosine of theta plus j times r sine of theta. Fine. Uh, Now coming back to our voltage equation, now we have Vt equal to Vm cos of omega t plus phi. So this is our uh, sinusoidal form of our voltage equation. Uh, Remember from this equation, from this last equation that we have here, z equal to r cos theta plus jr sin theta, you can see that r cos theta is what? R cos theta is nothing but the real part of z. Fine. Now Vt is equal to Vm cos of omega t plus phi. Since there is a cos term here, and you can also see here that the cos term is real part of some complex number, so you can say that this particular equation Vm, uh, this Vm cos of omega t plus phi is a real part of some complex number. I'm not writing that what is that complex number yet. So Vm cos of omega t plus phi is a real part of some complex number. Fine. Now if we have cos of omega t plus phi, Vm here, let Vm be the amplitude, omega t plus phi be the angle, then we can say that that complex number will be what? Vm cos of omega t plus phi plus j Vm sine of omega t plus phi. So Vt is equal to real part of this complex number. Real part of, when we actually break down this, the real part is only Vm cos of omega t plus phi. We'll get back this original equation, that is Vt equal to Vm cos of omega t plus phi. So real part of what? Vm cos of omega t plus j Vm sine of omega t plus phi. This is our rectangular form. We can represent this in terms of its exponential form. From the exponential form, we have z equal to r e raised power angle r e raised power j theta e raised power j. The angle here is omega t plus phi, where r is Vm here. Here r is Vm, that is the magnitude of this complex number, and theta here is omega t plus phi. So real part of Vm e raised power, breaking down this exponential, this is e raised power j omega t plus e raised power j phi plus j phi, so which implies real of Vm e raised power j omega t into e raised power j phi. You can write it like this, j phi real of Vm e j phi. I will write this as V, capital V, e raised power j omega t. Now this Vt is real part of some capital V e raised power j omega t, where this capital V is what? Vm into e raised power j phi. Now this V, capital V, is the phasor representation of our voltage, of AC voltage. Vt equal to Vm cos of omega t plus phi is the sinusoidal representation. Capital V equal to Vm e raised power j phi is the phasor representation of our AC voltage. Now e raised power j phi is actually an exponent, is actually a complex number, so you can write it in polar form as well. So in polar form it will be simply written as Vm angle phi. So this is actually the form that we mostly used for representing an AC voltage. Fine. So this is the phasor representation of our AC voltage. Capital V equal to Vm angle phi, while as Vt equal to Vm cos of omega t plus phi is the sinusoidal representation. So if you have any voltage given a sinusoidal form, you can directly say what is its phasor representation. If you have any voltage that's given to you in the phasor form, you can directly say what is its sinusoidal representation. So you have Vt equal to Vm cos of omega t plus phi. This is one way of representing your AC voltage, or V equal to Vm angle phi. This is another way of representing your AC voltage. One is the sinusoidal form, another one is the phasor form. Now this is a trigonometric form. This is actually a complex number here. Vm angle phi actually represents a complex number. So if this is a complex number, you can also show it on a complex plane having the real axis and the imaginary axis. Fine. So we will be any number having a magnitude of Vm uh, and an angle of uh, making an angle of phi with the real axis. So therefore V here is a vector. So AC voltage is basically a vector. AC in phasor form is a vector quantity. Uh, Vm sin cos omega t plus phi. We cannot say that is a vector quantity, but the phasor form of V of our AC voltage is a vector quantity, and it has by vector you actually mean it has both magnitude as well as direction. So if this representation here is actually known as the phasor diagram. When you actually show the uh, plot of the vector v on the complex plane, that plot is actually known as the phasor diagram. You can also say simply state that plot of any phasor uh, representation of your AC voltage on the phase diagram is known as the on a complex plane in the complex plane is the phasor diagram of your AC voltage. So now let's yeah, on this page. Okay, so you have the sinusoidal form now and you have the vector form now. So let us differentiate between these two forms. Although they are representing the same AC signal, there is no the voltage, AC voltage will be same. Mathematically, you can draw a comparison between these two. So sinusoidal signal is actually a time domain representation. Vt equal to Vm cos of omega t plus phi. Uh, you are actually your voltage is actually a function of time, and you can say that your representation is a time domain representation. While as in case of a phasor representation, you can say it is a phasor domain representation, or you can even say it is a frequency domain representation. ये frequency domain representation कैसे वो हम आगे जाके देख लेंगे. For now, let us keep it like that. So one is the time domain representation of your same AC waveform. Another one is the phasor domain representation of your waveform. So if you have some quantity like Vm, uh, Vt equal to Vm cos of omega t plus phi, its equivalent in the phasor domain will be V equal to Vm angle phi. Fine. So similarly, if Vt is equal to Vm sine of omega t plus phi, then its equivalent phasor will be Vm angle 90 degree minus phi. Third point, since this is a time domain representation, it actually gives us the instantaneous value. You can say instantaneous value of AC voltage. So at any time t, you can actually find out what is your AC voltage. Uh, so that's what you will be obtaining from the time domain representation. But in case of a phasor domain representation, you cannot find out the instantaneous voltage, but you can actually find out the frequency of this particular system. Fine. So ये frequency domain representation है. Let me write it for now. It is frequency domain based. It's not time domain based. ये जो Vt है, it is real. Vt is Vm cos of omega t plus phi. It's a real number. It is not a complex number. While as V, the phasor representation, is a complex number. Fine. Even if Vt is equal to Vm sine of omega t plus phi, in by itself, it's still a real number only. इसके साथ कोई j term तो associated नहीं है. It is still a real number, but your phasor is a complex number and it represents actually a complex value. So this also is a vector quantity. It has both magnitude as well as direction. This is time dependent. There is no this phasor representation. There is no time as a, it's not a function of time, so it is time independent. Waveform तो आपकी same ही है. These are simply two different representations of representing the same waveform. One is on a simple V versus one plot will be simply with respect to time. Another plot will be actually in a complex plane, and therefore one plot, if it is a sinusoidal waveform, another plot it will not be a sinusoidal representation. It will actually be circular representation. ठीक है. तो जैसे साइनसॉइड्स की पॉइंट वेक्टर है या स्केलर आपने नहीं लिखा है. So this is your AC voltage Vt. Uh, we are we have its plot with respect to omega t. It's a sinusoidal plot. Then you have a complex plot of this particular quantity V. Fine. So this particular depending upon whatever phase your system is actually making, your phase will actually be constant. Phase यहाँ पे change नहीं हो रहा है, वो आपको ध्यान में रखना है. ये जो phase है यहाँ पे phi, this will be constant for a system. Omega t is varying, but phase is not varying. Phase will be fixed. So your vector representation of this quantity will always on this complex plane simply be one vector uh, pointing in a certain direction given by the phase of this quantity. Phi is fixed for a system If phi is varying, then that will be a different thing. Phi actually vary नहीं होता है. So your quantity on a phase, your sinusoidal quantity that was on a time axis plot will be represented by a simple vector in the complex plane in the phasor when we are representing it in the phasor plot. जैसे मैंने आपको बताया, this plot is known as the phasor diagram. Now this phasor diagram is actually very important in electrical engineering. We'll be studying phasor diagrams of almost every machine, of every system that will be taking up in power systems across everything. Even in this course, for different circuits, we'll be plotting the phasor diagram, and we'll be seeing what will be the phasor diagram of these circuits. So phasor diagram will now simply be a vectorial representation of our quantity of our voltage or current. Now, if our जैसे कि मैंने आपको last time बताया, we can have different functions V1 and V2. So one function can be having a leading phase, another function can be having a lagging phase. So how we can show that on a phasor diagram is, lagging phase means your angle will be negative. So all such vectors that will be located in the fourth quadrant will represent lagging quantities. All such quantities that will be having a positive phase, that is between 0 and 90 degrees, they will be referred to as leading vectors. Fine. And every other quantity that will be actually located on the x-axis itself, that will be in phase. ठीक है? Yeah, you can say zero phase, or we can let me write it as zero phase. Zero phase हम आगे जाके पावर फैक्टर भी पढ़ने वाले हैं, तो वहाँ पे ये और ज़्यादा क्लियर हो जाएगा. So you can have three different vectors. One vector can be in the first quadrant. All such quantities that are in all those vectors that will be plotted in the first quadrant, they will be referred to as leading vectors. All those vectors that will be plotted in the fourth quadrant, they will be referred to as lagging vectors. All those quadrants that will be uh, along the x-axis direction, they will be referred to as uh, having a zero phase. तो ये तो हो गया फेजर रिप्रेजेंटेशन. वन मोर थिंग. Now say for example you have a quantity Vt equal to Vm cos of omega t plus phi in the sinusoidal form. If we differentiate this quantity dV by dt, Vm sin omega t plus phi, and also the internal differentiation, also यहाँ पे negative sign आएगा upon differentiation, so the internal differentiation will simply be omega. तो यहाँ पे omega आ गया हमारा. ठीक है. So dV by dt is minus Vm omega sine of omega t plus phi. We can also write this as minus omega Vm. We can drop the minus sign here. Omega Vm cos of omega t plus phi plus 90 degrees. So जैसे as you know, once you actually have a quantity cos of omega t plus phi plus 90 degrees, वो minus sign automatically आपकी compensate होगी. ठीक है. So अब हमारा एंगल यहाँ पे क्या है? It is what? It is phi plus 90 degrees. So in the phasor form, this will be represented by Vm angle phi plus 90 degrees. और यहाँ पे ओमेगा भी है. अब ओमेगा Vm angle phi plus 90 degrees. So original Vt was Vm cos of omega t plus phi. Original V was Vm angle phi. So once we differentiate Vt, we have found that the new phasor representation is omega Vm angle phi plus 90 degrees. Fine. So ये जो plus 90 degrees है, we can also represent that by j, that is the complex number, omega j Vm angle phi. ठीक है, तो ये आपका नया phasor representation हो गया. Original phasor representation was Vm angle phi. If you differentiate dV, आप differentiation of complex number तो नहीं कर सकते. So what we have done is we have differentiated the sinusoidal form. We have found out the new phasor quantity. So the new phasor form is this. So this is actually your V dash में यहाँ पे लिख दूंगा. V dash is actually the differential form of your original phasor. So you can see upon differentiating the phasor, what happens is your omega and j get multiplied with your original phasor. So if V is, ये आपका normal form है, V equal to Vm angle phi, your differential form for this quantity is what? V equal to omega j Vm angle phi, or you can simply write omega j, V is already Vm angle phi, omega j into V. So V dash is equal to omega j into V, where V is Vm angle phi. ठीक है. So we have differentiated the cosine form and found out that the new phasor form will be omega j Vm angle phi. So V dash can be written now. Differential form of the phasor is V omega j into V. Yes. अब वो करने की जरूरत नहीं है, हमने कोसाइन से भी कर लिया. अब आप वैसे भी कर सकते हो, एक्सपोनेंशियल फॉर्म से भी कर सकते हो. डायरेक्टली Vm एंगल फाई को तो आप कर नहीं सकते ना. You can do it from the exponential form, you can do it from the trigonometric form. So we have and simply differentiated the sinusoid and we can get the new phasor. So that will be the differential form of our original phasor. So the differential form of our new quantities omega j v. Similarly, ये तो हो गया डिफरेंशिएशन अगर हम कर रहे हैं. अगर हम इंटीग्रेशन कर रहे हैं, v dash will be v divided by ओमेगा j. ठीक है, तो ओमेगा j आपका मल्टीप्लाई हो रहा है या ओमेगा j आपका डिवाइड हो रहा है. फाइन. अब ये एक्चुअली हम कहाँ पे यूज करेंगे? विल बी यूजिंग दिस इन inductors and in capacitors, because you know that the current through a inductor is di by dt. So whatever was the original current equation, you have to actually obtain its differential form. So you can simply multiply there the phasor by omega j, as well as in capacitors you know that I v is equal to 1 by c and the integral of I dt. So instead of writing that, you can divide by omega j. तो ये वहाँ पे हम use करेंगे. We'll see this once we take up integrate inductors and capacitors. So by differentiation omega j multiply हो जाएगा, by integration omega j divide हो जाएगा. Doing some questions before we proceed on. So you have two functions. You have v1 t equal to this thing. You have v2 t equal to this thing. So you can represent their phasor forms also. v1 will be what? 20 angle कितना होगा? This is in sine, so this will be 30 plus 90, so that means 120 degree. v2 will be 30 angle 90 plus 90, that means 180 degrees. ये तो ये हो गया, एक तो ये क्वेश्चन है आपका, इसका फेजर रिप्रेजेंटेशन निकालना. दूसरा क्वेश्चन मुझे बताओ, v1t and v2t, among these two which one is leading and which one is lagging? लीडिंग कौन सी है एंड लैगिंग कौन सी है?
So leading V1
Is v1 leading v2 or v2 is leading v1? ये आपका से फॉर एग्जांपल ओमेगा टी एक्सीज है, v1t आपका -30 से स्टार्ट हो रहा है, उसके बाद जो भी है, ठीक है. v2t आपका -90 से स्टार्ट हो रहा है. दिस इज v1, दिस इज v2, स्टार्टिंग फ्रॉम -90. अब बोलो v1 लीडिंग है कि v2 लीडिंग है?
leading.
So v2 is leading, v1 is lagging. ठीक है. हम्म, फेज से आप you have to take them as a reference of each other. ठीक है. So if you take, say for example, v1 is somewhere here, you can take it, let v1 be in this direction. कौन सा ग्राफ? v1 is 20 sine of omega t plus 30. So that means when omega t will be equal to -30 degrees, this angle will be 0, sine 0 is 0. तो ये कहाँ से start होगा? This will be 0 from -30 degrees. v1t will start, v1 will be 0 at -30 degrees. So उसके बाद simply आपको sinusoidal waveform बनानी है, and it will, अब 0 पे कितना वैल्यू होगा वो आप देख सकते हो. v2t at omega t equal to -90 degrees, this angle will be 0, sine 0 will be 0, so it will be 0 at -90 degrees. So it will start from there. So you can see that v2 has already started, v1 is starting much later. So v2 is leading, v1 is lagging. आपके पास है फॉर एग्जांपल v1t is 20 cos omega t plus 30 and v2t is 20 cos 20 sine omega t plus 60 degrees. Whenever you have to make the comparison, frequency has to be same. If frequency is different, then you cannot actually compare them. Now you have v1t equal to this, v2t equal to this. इनमें से बताओ कौन सी लीडिंग है, कौन सी लैगिंग है? अच्छा, -60 डिग्रीज. अब बताओ कौन सी लीडिंग है, कौन सी लैगिंग है? दोनों बराबर है, दोनों will be in phase. So when you have to compare, एक तो frequency भी बराबर होनी चाहिए, दूसरी आपकी ये जो cos और sin है ये भी बराबर होनी चाहिए. Once you convert this into cos, this becomes plus 90 degrees. Minus 60 plus 90, this becomes plus 30. So both are plus 30 degrees. So they are actually the same quantities. ये यहाँ पे 5 minus 90 था, not 90 minus 5. Solve this. You have a current I, 4IT plus 8I dt minus 3 di by dt equal to 50 cos 2t plus 75 degrees. तो इसमें से बताओ IT किसके बराबर आएगा? अभी जो फेजर का कंसेप्ट हमने किया, using that find out what is the value of IT here. We can represent this in its phasor form. Fine. So 4 IT की जगह पे आपका I है plus 8 इंटीग्रल ऑफ IT की जगह पे आप I डिवाइडेड बाय j ओमेगा लिख सकते हो, माइनस 3 DIT की जगह पे आप j ओमेगा इंटू I लिख सकते हो, इज इक्वल टू on the right hand side the phasor form is 50 angle 75 degrees. So from here you can now take I common, अंदर आपका 4 plus 8 divided by j omega आएगा minus 3 j omega equal to 50 angle 75 degrees. So I is equal to 4, this is what ओमेगा 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 आपका क्या है, ओमेगा आपका ये है, ओमेगा इज इक्वल टू 2, 4 plus 8 by 2 is 4 divided by j minus 3 into 2 6j equal to 50 angle 75 degrees, which implies I is equal I into 4 minus 10j is equal to 450 angle 75 degrees. So I is equal to 50 angle 75 degrees divided by 4 minus 10j. ये किसके बराबर आएगा? You can directly do this on the calculator. Hmm. टू जे नहीं आएगा, दिस इज 4 डिवाइडेड बाई जे. जब जे ऊपर जाएगा ये माइनस जे बन जाएगा. माइनस 4j माइनस 6j, ये कितना आएगा? 10. 4.642 एंगल 143.2 degrees. Fine. So this is the phasor form. You can now directly write the sinusoidal form. It is equal to 4.642 cos ओमेगा t आपका वही है जो पहले था 2t प्लस 143.2 डिग्रीज एम्पियर्स. ठीक है, ये भी एम्पियर्स में. हाँ, किसी को कोई क्वेश्चन है?
फर्स्ट क्वेश्चन में एंगल कैसे फाइंड किया था?
किस फर्स्ट क्वेश्चन में?
फर्स्ट इलस्ट्रेशन. यस सर.
विच एंगल?
सर फेजर में एंगल.
ये
नो सर, फर्स्ट इलस्ट्रेशन v1 and v2.
v1 and v2 on this page.
यस सर.
ओमेगा टी प्लस पाई माइनस 90 जैसे मैंने बताया आपको, दिस विल बी पाई माइनस 90. ठीक है, तो ये मैंने करेक्शन अभी करवाई थी एक्चुअली. दिस विल बी 5 minus 90, that is 30 minus 90, that is minus 60. 90 minus 90 ये 0 होगा.
ओके सर.
इतना ही करेंगे. यहाँ पे भी ये 5 minus 90 है, ये minus 60 minus 90 minus 150 बन जाएगा. minus 150. So this will not be actually in phase, ये actually out of phase होंगे. ठीक है, इक्वेशन ये है आपकी. इक्वेशन ये है Vt is, if Vt Vm sine of omega t plus phi, then its phasor representation is Vm angle phi minus 90 degrees. Yes. कौन सा लास्ट? वो आप डायरेक्टली कैलकुलेटर पे कर सकते हो. नॉर्मल कैलकुलेशन से भी हो जाएगा. ये आपका 4 माइनस 10j है, इसमें से आप r निकालो, इसमें से आप एंगल निकालो, फिर आप उसको r एंगल थीटा फॉर्म में निकाल सकते हो. फिर आपका जो इसका r एंगल थीटा कितना आएगा ज़रा मुझे पहले बताओ. इसका अगर आपके पास कैलकुलेटर नहीं होगा, 50 एंगल 75 नीचे 4 माइनस 10j, 50 एंगल 75 4 minus 10j is इसका r under root of 4 square plus 10 square, that is under root of 116 square, that is r. Angle is tan inverse of 10 divided by 4. ठीक है, तो यहाँ पे जो भी एंगल आएगा, तो तो आपका जो मैग्नीट्यूड है अब दैट इज 50 एंगल 50 डिवाइडेड बाय अंडर रूट ऑफ -116, और जो आपका एंगल है दैट इज 75 माइनस tan इनवर्स ऑफ 10 डिवाइडेड बाय 4। ठीक है, तो वो एंगल आपने को निकालना है, तो दैट विल बी योर एंगल। अल्टीमेटली आपका आंसर तो यही आएगा जो यहाँ पे है। या फिर आप ऊपर वाली इक्वेशन को एक कॉम्प्लेक्स में रिप्रेजेंट कर दो। दिस विल बी 50 cos 75 प्लस j 50 sin 75, फिर you have one complex number divided by another complex number, so you have to go for rationalization and find out the answer. If in case you do not have a calculator, अगर आपके पास calculator है, आप directly angle divided by complex number represent divide कर सकते हो। अब फिर वो आपको कैलकुलेटर में सेटिंग्स आ जाती हैं,